A silent summer night. Families asleep. Cities glowing under streetlights. And far above, in the endless black sky, something is moving. It's ancient, cold, and deadly. A mountain of rock and metal, speeding through space at 40,000 miles per hour. Invisible to the naked eye, but locked on a path with Earth. If it hits, the shockwave could flatten continents. The tsunamis could swallow coastlines. The skies could darken for years. Humanity would face its greatest test. The terrifying question is, if we saw it coming, could we stop it? Welcome to HEH TV, where we explore the mysteries of our universe, the hidden truths of history, and the science shaping our future. If you're ready to dive into a story that could decide the fate of our planet, stay with us till the end. Our planet is no stranger to cosmic violence. The evidence is carved into its surface. Take Arizona's meteor crater. Today, tourists drive up, snap photos, and stare down into a giant hole 1 mile wide. But that crater wasn't made by volcanoes or earthquakes. It was created about 50,000 years ago, when a chunk of iron rock only 160 feet across slammed into the desert. That tiny asteroid, tiny compared to planet killers, released more energy than hundreds of nuclear bombs. Now fast forward to 1908, deep in Siberia. Dawn had just broken when people saw a flash in the sky. A fireball exploded above Tunguska, flattening 80 million trees over 800 square miles. Witnesses felt heat like standing near a blast furnace. Had it exploded over New York, London, or Tokyo, millions would have died in an instant. And then, much more recently, 2013. A normal winter morning in Chelyabinsk, Russia. Dashcams picked up a streak of fire racing across the sky. Suddenly, an explosion. Windows shattered in thousands of homes. More than 1,000 people were injured by flying glass, and this rock was just 60 feet wide. These were small compared to the monsters still out there. 66 million years ago, an asteroid 7 miles wide slammed into what is now Mexico's Yucatan Peninsula. The impact vaporized rock, ignited global wildfires, and filled the skies with dust that blocked sunlight for years. Dinosaurs didn't stand a chance. That single event rewrote the history of life on Earth, clearing the way for mammals and eventually us. So here's the chilling truth. It's happened before, and it will happen again. The only question is whether humanity will be prepared next time. Stopping a planet killer starts with seeing it coming. Right now, NASA, the European Space Agency, and observatories around the world are scanning the skies every night. Programs like Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona search for faint moving dots against a backdrop of stars. These dots are near-Earth objects, asteroids, whose orbits cross paths with our planet. Scientists have already cataloged over 30,000 of them. But here's the scary part. We think there are at least 25,000 asteroids, bigger than 460 feet across, still undiscovered. And those are the city killers. Anything a kilometer or larger is a civilization killer. The problem is, space is big and asteroids are dark. Many sneak in from the direction of the sun, where our telescopes can't see. If we discover one of those with only months or worse, days before impact, there's nothing we can do. Detection is everything. Without years of warning, there's no chance of survival. Let's imagine the best-case scenario. Scientists spot a massive asteroid heading our way, but decades before impact. What options do we have? The first method is called the kinetic impactor. It's exactly what it sounds like. smash a spacecraft into the asteroid to knock it slightly off course. In 2022, NASA tested this idea with the DART mission. A small spacecraft rammed into the asteroid moon Dimorphos, changing its orbit around a larger asteroid. The change was small, just minutes. But in space, small changes over years mean the difference between a miss and a direct hit. Another option is the gravity tractor. Imagine parking a heavy spacecraft near the asteroid and just sitting there. Gravity, weak but steady, would slowly tug the asteroid onto a safer path. It would take years, but it's precise and avoids breaking the rock into dangerous fragments. Some researchers propose using lasers or giant mirrors to focus sunlight onto the asteroid. Heat would vaporize material off the surface, and that escaping gas would act like a natural thruster, nudging the rock away. And then there's the nuclear option, the most dramatic and the most controversial. A nuclear explosion near the asteroid could either blow it apart or vaporize part of its surface, changing its trajectory. But the risk is high. If the asteroid shatters into pieces, we might turn one giant bullet into a shotgun blast of smaller, but still deadly projectiles. Hollywood made this look easy in movies like Armageddon. In reality, the engineering challenges are enormous. But make no mistake, nuclear devices may be our last line of defense if nothing else works. Technology is only half the battle. The other half is political. Imagine astronomers discover an asteroid that will hit Earth in 25 years. Who decides what to do? The United States? Russia? China? What if the asteroid's path could shift, threatening different countries over time? Could nations agree to share resources and make a decision quickly enough? The good news is that steps are being taken. NASA has a Planetary Defense Coordination Office. The European Space Agency is building its own missions. The United Nations has committees for space cooperation. But in a real emergency, where every year counts, would humanity act together or waste time arguing? That's the question we don't yet know the answer to. 66 million years ago, a calm day turned into the last day for the dinosaurs. A chunk of rock, nearly 7 miles across, slammed into the Yucatan Peninsula. The ground shook across continents. Tsunamis surged taller than skyscrapers. Firestorms circled the globe. And then came the silence. Dust, ash, and vaporized rock filled the skies, blocking sunlight for years. Plants withered. Food chains collapsed. 3 out of every 4 species disappeared, including the dinosaurs that had ruled Earth for over 150 million years. That asteroid didn't just kill. It reset the planet. It cleared the stage for mammals and eventually humans to take over. But it also delivered a warning. If it happened once, it will happen again. The dinosaurs didn't have telescopes or rockets. We do. That difference might decide if we share their fate or survive. The dinosaur killer wasn't the only one. Our planet is littered with craters, each a scar of past cosmic violence. In South Africa lies the Vredefort crater, 2 billion years old and over 180 miles wide, the largest confirmed impact on Earth. In Virginia, the Chesapeake Bay crater formed 35 million years ago, when a rock 2 miles wide slammed into shallow seas. In Arizona, the Barringer crater shows the force of even small impacts, just a few hundred feet of rock carving a hole nearly a mile wide. Each crater is a warning carved into stone. Earth is not a safe island. It is a target in a shooting gallery. If all this feels like ancient history, remember Tunguska in 1908. A rock, maybe 150 feet wide, exploded in the sky with the power of 15 megatons of TNT. 80 million trees fell like matchsticks. Or Chelyabinsk in 2013. That rock was only 60 feet across. No craters were left, but the shockwave injured over 1,000 people. Imagine if it had been 600 feet wide instead. The odds of a civilization-ending asteroid in any given century are low, maybe 1 in 10,000. But given enough time, it's guaranteed. Asteroids don't care about calendars. The real gamble is whether we'll be ready when one finally sets its sights on us. How do we prepare? By finding them before they find us. Right now, scientists are in a race against the clock. NASA's NEOEYES telescope scans the skies from space. Ground observatories like Pan-STARRS in Hawaii track faint dots night after night. And soon, the Vera Rubin Observatory in Chile will change everything, capturing the entire sky every few nights and revealing thousands of new asteroids. But here's the catch. We're still blind to many threats. NASA estimates that we've only found about 40% of the dangerous ones larger than 460 feet. Tens of thousands remain unseen. Some are dark, carbon-rich rocks that absorb most sunlight. Some approach from the direction of the sun, where telescopes can't look. Those are the true nightmares, the ones we might not spot until they're almost here. That's why NASA is preparing the NEO Surveyor, a new infrared space telescope set to launch later this decade. Instead of depending on sunlight, it will detect the heat of asteroids themselves, making the invisible visible. For the first time, we may finally get a complete map of the threats around us. Let's imagine we don't see it in time. A planet killer is coming. What happens then? A 500-foot asteroid slams into the ocean. The water rises in walls, taller than skyscrapers. Coastal cities like Miami, New York, and Los Angeles vanish under waves. Millions die within hours. A 1-mile-wide asteroid hits land. The explosion is equivalent to millions of nuclear bombs. The fireball incinerates everything within hundreds of miles. Shockwaves flatten states. Dust and ash plunge the earth into years of freezing darkness. Crops fail. Nations collapse. A 7-mile-wide asteroid, like the one that killed the dinosaurs, makes Earth unrecognizable. Humanity may survive in small pockets, but civilization as we know it ends. This isn't science fiction. It's math. The energy of an asteroid is simple physics: mass, velocity, impact. And space is filled with them. So what's the plan? First, detection. Without early warning, we have no chance. With decades of warning, even the smallest nudge can save us. That's what made NASA's DART mission historic. In 2022, a small spacecraft slammed into an asteroid moon called Dimorphos, changing its orbit. For the first time in history, humans altered the path of a celestial body. It was proof that we don't have to be powerless, and it's only the beginning. The European Space Agency is launching a mission called Hera, which will revisit Dimorphos and study the crater left by DART. Together, these missions are building the playbook for planetary defense. But there's a problem no rocket can solve: politics. Imagine scientists announce that an asteroid will hit Earth in 25 years. Who takes charge? The United States? China? The United Nations? And what if the asteroid's predicted path crosses first over Africa, then shifts toward Europe? Nations might argue, delay, or even fight over control of the mission. Stopping a planet killer isn't just science. It's global cooperation. Without it, all the technology in the world won't matter. Here's something fascinating. Asteroids aren't just threats. They're also opportunities. Many are rich in metals platinum, nickel, even water ice. Some scientists believe mining asteroids could fuel future space industries. And the same technology that lets us capture and redirect asteroids for resources could be used to defend Earth. In other words, the line between survival and progress might blur. Saving Earth could also open the door to humanity's expansion into space. We've seen the scars of past impacts. We've watched the Dark mission prove that we can change an asteroid's path. But the truth is, when it comes to stopping a planet killer, one method won't be enough. The danger is too big, and the clock might be too short. So, what tools do we actually have to save Earth? The simplest idea is to hit the asteroid with a spacecraft. Think of it like a cosmic bumper car. This is exactly what DART did in 2022. A spacecraft the size of a vending machine slammed into Dimorphos, a rock almost the size of a football stadium. The result? Its orbit shifted by more than 30 minutes. Scientists had only hoped for 10 minutes. That small nudge was enough to prove the concept. If we have years or decades of warning, hitting an asteroid hard and fast could shift it off a collision course with Earth. But here's the catch. The asteroid DART targeted was relatively small and not dangerous. A true planet killer might be miles across, far heavier, and harder to move. One impact may not be enough. We might need dozens. And to hit the right spot, we'd need precise calculations and flawless execution. If we don't have decades of warning, scientists have considered something more extreme: nuclear weapons. The idea isn't like Hollywood movies where we blow the asteroid to pieces. In reality, that would be dangerous, creating many smaller but still deadly fragments. Instead, the plan would be to detonate a nuclear device near the asteroid's surface. The blast would vaporize part of its surface, creating a jet of gas and rock that pushes the asteroid slightly off course. It sounds dramatic, but simulations suggest it could work, especially for larger asteroids. The problem is politics. Launching nuclear weapons into space is restricted by international treaties, and the world would need to agree who gets to control them. Still, in a desperate scenario, the nuclear option might be the only card left to play. Imagine a spacecraft parking next to an asteroid and simply hovering there. Its tiny gravity pulls on the asteroid, and over years, this gentle tug shifts its orbit. This is called a gravity tractor. It's elegant, safe, and doesn't risk breaking the asteroid apart. The downside? Time. It only works if we spot the asteroid decades in advance. Without early detection, gravity tractors are useless. Other ideas sound like science fiction, but are taken seriously by scientists. Solar sails. Attaching giant reflective sails to an asteroid could let sunlight itself push the rock slowly off course. Lasers. Powerful lasers stationed in space could heat one side of the asteroid, creating jets of vapor that nudge it away. Both methods rely on technology we don't fully have yet, but they may become real options in the future. Here's the nightmare scenario. We spot a large asteroid only months before impact. None of the above methods would work in time. In that case, humanity would face disaster response, not prevention. Evacuations, underground shelters, stockpiling food. It would look less like saving the world and more like surviving its collapse. That's why early detection is everything. The sooner we see the threat, the more options we have. Interestingly, the technology we develop for defense could also serve exploration. NASA once planned the Asteroid Redirect mission, aiming to capture a small asteroid and bring it into orbit around the Moon. Though canceled, the research contributed to understanding how to move asteroids safely. China, too, has announced plans to test asteroid deflection technology. In the 2030s, it may send a mission to hit an asteroid multiple times, testing whether repeated impacts can shift its orbit. Planetary defense is no longer just a Western project. It's becoming global. Every deflection method depends on one thing: time. With 30 years of warning, a gravity tractor or solar sail could work. With 10 years, multiple kinetic impacts might be enough. With 5 years, we might need nuclear devices. With 1 year or less, there may be nothing we can do. That timeline shows why investment in detection is critical. The earlier we spot the danger, the gentler and safer the solution can be. Wait too long, and all that's left is desperation. Here is a striking fact. NASA's planetary defense budget is about $200 million per year. That sounds big, but compared to the Pentagon's annual budget over $800 billion. Humanity spends more on weapons to fight each other than on defending the entire planet from extinction. It would only take a fraction of global military spending to fund full planetary defense. More telescopes, more test missions, more international coordination. The knowledge and technology are within reach. What's missing is urgency. Ask the average person about asteroid impacts, and many think it's just Hollywood fantasy. Movies like Armageddon or Deep Impact turn the idea into entertainment. But scientists stress that this is not fiction. The probability is low in our lifetime, but not zero. Over millions of years, the odds of a planet killer are 100%. This disconnect between perception and reality is dangerous. If people don't take the threat seriously, governance won't fund prevention. And when the day comes, we may find ourselves scrambling too late. The year is 2085. A space observatory scans the night sky and finds a dark object moving against the stars. At first, it seems like nothing. Just another rock drifting through space. But then, the orbit is calculated, the numbers line up, and the truth hits like ice. It's coming. It's big. And in less than 20 years, it will hit Earth. That scenario isn't science fiction. It's exactly what planetary defense experts prepare for. And the question remains, will humanity be ready? Let's be clear. Not every asteroid is a planet killer. Most are small. Most burn up in the atmosphere or splash harmlessly into the ocean. But every few million years, one arrives that is truly catastrophic. The dinosaurs faced it 66 million years ago. Their world ended in firestorms, darkness, and famine. If a similar-sized asteroid hit today, billions could die. Nations, economies, and cities would vanish overnight. Scientists call these events low probability, high consequence. The chance in any given century is small, but across deep time, it's inevitable. This is why planetary defense is not just science. It's survival strategy. Here's where things get complicated. Saving the planet isn't just about rockets and telescopes. It's about politics. Imagine an asteroid headed toward Earth, but its exact path is uncertain. At first, the probability shows it might hit in the Pacific Ocean. Then the calculations shift. Now it's the United States, and maybe Africa. Each update changes who is most at risk. Would nations cooperate? Or would they fight over resources and control? Who decides when to launch a nuclear deflection? Who pays for the mission? These are questions humanity hasn't answered yet. And time wasted in argument could be the difference between success and failure. The encouraging part is that we already have the seeds of a solution. Telescopes like NASA's upcoming NEO surveyor, launching later this decade, will find thousands of hidden asteroids. Radar networks can map their paths with extreme precision. Test missions like DART have proven we can nudge an asteroid. Combine these tools with advanced AI to predict trajectories, reusable rockets to cut costs, and international agreements for coordination, and we could build a planetary shield in all but name. Think about what's at stake. Humanity has spent thousands of years building civilization. Every library, every song, every invention, every dream of the future, all could be erased in a single impact. But unlike the dinosaurs, we have brains that can see the danger coming. We have tools to change our fate. The asteroid doesn't have free will. It doesn't aim for us. It's just physics. And physics can be changed. This makes the asteroid threat unique. It's one of the few natural disasters we can actually prevent. We can't stop earthquakes. We can't stop volcanoes. We can't stop hurricanes. But we can stop a rock in space. That fact alone should unite us. So what might happen if humanity does nothing? Best case, nothing hits us for centuries, and people keep calling planetary defense a waste of money. Worst case, a mile-wide asteroid is spotted too late, and history repeats itself with us in the role of the dinosaurs. But if we act now, imagine a different story. It's the year 2130. A dangerous asteroid is found. Telescopes track it. Computers calculate the impact date. A fleet of spacecraft launches. They strike the asteroid years before it gets close. Its orbit shifts, and the rock passes harmlessly by. Billions of lives are saved, and most people barely notice. Humanity becomes the first species in Earth's history to defend itself against extinction. That's not fantasy. That's possible if we decide to make it so. So, can humanity stop a planet-killing asteroid? The answer is yes, but with a warning. Science gives us the tools. Time gives us the options. But only unity gives us the chance. The dinosaurs never saw it coming. We can. The question is whether we'll take that gift seriously before the countdown begins. Because the asteroid is out there, somewhere in the darkness. It may not arrive tomorrow, or in our lifetimes, but someday it will. And on that day, the story of humanity will face its greatest test. Do we vanish like those before us, or do we rise, and for the first time in history, save not just ourselves, but the world?